Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm very excited to be talking with Dr. Jane Melia today, co-founder and CEO of Harvest Thermal. We're going to talk about the challenge of decarbonizing building space and water heating. Something like 75% of a home's energy demand is due to heating space and water. When that heat comes from burning methane, it's a significant source of emissions. So a solution many are turning to, including myself recently, is to use electric heat pumps. The problem with that is that home heat demand spikes when solar energy supply is low, meaning we have to burn fossil fuels to supply electricity to power the heat pumps, which partially defeats the purpose. Jane and her team at Harvest Thermal are solving this with a new approach and a smart piece of hardware that I'm excited to learn more about. Customers who are using their system today are cutting carbon emissions by 90% compared to using gas, and impressively by 50% even compared to heat pumps. They're also saving as much as 48% on their utility bills. Jane herself is an experienced startup executive. She has a PhD in fluid dynamics and has been a leader in companies focused on renewable energy, cybersecurity, and IT. I've decided not to list all of the awards she and Harvest Thermal have won recently, or we'd run out of time. But one that stands out to me is Jane was named on Entrepreneur Magazine's list of 100 Women of Influence in 2022. Jane, it's really an honor to have you on the show. Thanks a lot for joining us.
Thank you very much, Dylan, for the introduction, and thanks for having me. So it's super excited to be here.
Yeah, I'm excited about it. Speaking of awards, the last time I saw you, we were just talking about this. The last time I saw you was on stage with a trophy in your hands at the NREL IGF show. You won the People's Choice Award there. Congratulations.
Thank you.
And you've been racking up quite the impressive collection of hardware, it seems. Fast Company, world's most innovative companies, the Edison Award, Verge 22 pitch competition. So it's pretty impressive.
Yeah, I think it's a reflection that the growing awareness of the importance and the challenge of tackling the carbon emissions from our buildings. It is an area that until recently, we didn't really talk about much. We talked about how do we clean up our vehicles? That's really important. What about electricity? How do we make electricity generation cleaner? How do we transition from coal, add more renewables and wind turbines? And in fact, for many years in my career, I worked on solar energy, right? That's really important to do. And we weren't saying anything about buildings. Buildings overall represent as much in terms of emissions, if not more, as transportation. And yet it's something we haven't been talking about. So that is changing right now. And I think this series of awards, of course, it reflects the work of the team. The team's done huge work in developing a good product and bringing it to market. But it's also this awareness that this is important, it has an impact, and we need to get our act together on buildings as well as on the other parts of climate change if we really want to beat this thing.
Why do you think that's happening? What has changed now that's bringing more awareness to that?
Well, first of all, that understanding of the scale of emissions from buildings has started to sink in. We're dealing with some parts of the problem. We've left this one till now. And he's beginning to think this is 1/3 of overall emissions. What do we do about it? It's also, though, I think there's been a problem which has been hard to tackle because buildings are, of course, distributed. There are many of them, and buildings last a long time. And honestly, I don't know why it took us a while. I think we just had other problems to solve. And developing the technologies, such as heat pumps, such as solar, such as wind, was really the focus. How do we get the technologies ready? And now it's a question of, okay, so we've got some good technologies that are making electricity cleaner. How does this match with our buildings and the emissions they're releasing? And how do we really help solve that? And we're finding that it's not as easy as you'd think. As you were saying before, putting a heat pump in your home is great. You're electrifying the home. And if that grid is solar, that's going to be perfect. The challenge is most people don't primarily want to heat their home at noon. They want to heat their home at night and in the mornings. You can't tell your kids, sorry, we're not going to be warm until noon because that's when there's solar electricity. You need to use electricity for that heating and hot water whenever the family really needs it. And that is a mismatch. And that's one of the problems that we need to solve. And that's really what Harvest has been addressing.
And maybe in some ways, your own personal journey through clean energy technologies and climate matches that evolution. Can you talk a little bit about that? Where did you start in clean tech and how has that evolved to where you are today?
Absolutely. So I am an engineer, as you mentioned, civil engineer, PhD in fluid mechanics. I worked in large corporations for a while. And then I saw this huge importance and opportunity of developing renewable energy really became apparent to me. And I jumped ship and in 2008 joined a concentrator company called Sol Focus and worked for them for a number of years. Worked also for an energy storage company called Enervolt, consulted for a solar cell manufacturer called Solar Junction, worked for a while in quantum tech. So really passionate about how do we bring impactful innovation to market, but also becoming increasingly aware that we were not talking about that piece of the pie that we'll be mentioning, which is what about our buildings? What about our homes? That came to a head when my own gas furnace back in 2017 was about to die, not yet dead yet. There was no way I was going to replace it with another gas furnace, because if you put a gas furnace in today, it's going to stay in for 20 years. It takes us to 2040. That's too late. So, okay, I was thinking, well, I just put it in a heat pump. That meant a heat pump for space conditioning and a heat pump with a tank for hot water. They would run at night in the morning, and there is no solar electricity at night. So I need electrochemical battery. And you start to add that up. And I was thinking, wow, this is really expensive. I can barely afford this. This is not going to scale. And we cannot just electrify the homes of the well-meaning well-off. This has to be something that can be deployed in every home. And therefore, we need to get back drawing board. And that's when my co-founders and I were thinking, okay, how can we make this simpler? How can we make it more streamlined? Essentially, with one heat pump and one tank that you need anyway, and some really good controls, you can deliver heating and hot water and storage, getting rid of the need for gas for those huge loads for your home and allowing it to do the arbitrage, to get the cheapest cost, get the cleanest electricity, save you money, save emissions, and help that grid get cleaner. That's what we've developed. I've had it in my home since 2018. Based on those results, founded the company in 2019. And we've been building the team, building the technology, getting it certified, getting it manufactured, building those partnerships. And we launched commercially last year. In 2022, we have our contract manufacturing for our control unit in place in San Jose, California. And so we're deploying them. And proud to say that we've now sold about 75 systems. In fact, in Q1 of this year, we sold as many as in all of last year.
All right.
And our job right now is to get into as many homes as possible because it's all about impact. As I say, every time a gas furnace goes in, it's stuck for 20 years. We want to prevent those going in as quickly as we can.
I love that story, partly because you did what I think so many people are doing and looking at all the options out there. And what I did then as the next step, I just bought the best of the options available. But I love that you said, you know what, this isn't good enough. I'm going to go make something better and build that for myself. I just think that's so cool. I also, if I understand right, it sounds like your motivation was as much about finding a more affordable solution that could scale to many people as it was about reducing carbon emissions.
Yeah, absolutely. Individual action is important, right? We all need to do our part. But I think we're all aware that if we're the only ones who are able to reduce emissions, it's just not going to have an impact. And there is an equity play as well. As homes are transitioning from gas, people will be left behind, bearing the brunt, bearing the cost of that infrastructure. And unfairly, it's often the disadvantaged communities and people who are less able to make the transition to really high-end electric systems. So we need to make sure that these things are affordable, that they cut bills, and that everybody can have them. One thing I like about the system is because it is a tank, which many people have in their homes anyway, an air handler, which people have a furnace anyway, is actually using the footprint that people have in their homes with a smallish heat pump outdoors. So again, it works for large homes, but it also works for modest-sized homes. That's important too, being able to fit it into the footprint of the existing home.
Yeah, maybe just since we're on it, can you describe what the pieces are and how it all works together?
Yeah, absolutely. So what we're doing is delivering heating and hot water to homes, always using the cleanest, cheapest electricity. And we do that by integrating to our system a thermal battery, which is basically storage, and some really smart controls. So what it does is we take one high-performance heat pump. This heat pump is going to run in the middle of the day primarily, when electricity is clean, is cheapest, when it mostly comes from solar energy. That's going to generate hot water at high temperatures. And we store that in a tank. This is what our control unit is managing it really as a thermal battery, just as you would manage a Tesla Powerwall. And then that hot water is delivered both as your domestic hot water, but also as heating to your home using, for example, either radiant floor or more commonly using standard duct distribution to deliver that warm air through the ducts that you have in your home. What's really important is by having this tank operating as a battery, that allows us to completely decouple the times of day when that heat pump is operating from the delivery of heating to the home. That means we can choose when to use it. And we're going to typically run it in the middle of the day when there's a lot of solar electricity available on the grid, when that heat pump is going to be more efficient, because heat pumps are actually more efficient when it's warmer, and also allowing the homeowner to take advantage of time of use rates. So the system's more efficient and they can use lower rates, means that they're saving bills. As you mentioned, we're saving up to 48%. On average, our homeowners are saving 30% compared to gas in bill reduction, which means a lot, right? That at the end of the month, it's really good to have that money. And so that's what the system does. It's designed to work for existing homes, which is where we've done most of our deployments to date, but it also works for new homes. We've done a few of those. And it's smart, it's grid connected. We've demonstrated the ability to do demand response, to be able to really support that grid as it deals with peak loads and so on.
Yeah. So really that load shifting aspect of it is a huge part of the benefit.
Yeah.
And I think there's an important maybe visual for people, anyone listening, to go Google the duck curve. Could you describe what that is and why that's important?
Yeah, the duck curve is basically showing 24 hours in the life of the grid between midnight and midnight. And it shows that in the mornings and the evenings, you've got a lot more emissions from electricity generation and also higher costs to meet that need as the grid operator is ramping up gas peaker plants to meet the surge of load in the morning and the evening. In the middle of the day, you've got this low belly of the duck, right, going down because there's lots of clean, cheap solar. That's great. So if you plug a hairdryer in at noon, whether you've got solar panels on your roof or not, you're typically going to be using solar electricity. So that's really nice to know. The challenge is that works, for example, for shifting when you're going to use your dryer or your dishwasher or other electric appliances. But for heating, it's different. When you transition to a heat pump for electricity, for your heating, you're going to need to run that at night and in the morning. And so you're not really using that solar electricity in the belly of the duck. What Harvest Thermal is doing, and what I joke about, is we're like an upside down duck. We're able to use that electricity exactly when you've got the belly of the duck and then store it up in the tank, a nicely insulated tank, minimizing thermal losses, and delivering it in the evening, delivering it in the morning, just when your family needs that warmth. And so that's what's different. Heat pumps are fantastic technologies. They're moving heat rather than generating it. They are 3 times, 4 times or more efficient than even the best gas furnace. But what we're dealing with right now are what I call Gen 1 heat pump systems. They deliver that, but they're not yet smart enough to take the grid and the costs and the emissions into account. What Harvest is doing is saying, let's go to the next generation. Let's have Gen 2 heat pump systems whereby we can operate that heat pump when electricity is cleanest, when it's cheapest, always doing the arbitrage to give the minimum cost for the homeowner and the best support for that grid, but deliver the heating and hot water when you need it. I see that as the future of where we're going for heating and hot water for our homes. We need to decouple the two. We need to use heat pumps, and Harvest is using a heat pump, but we need to be able to control that in a better way. That means that we don't have this battle between, do we have a clean grid or do we have a clean home? We're able to have both. We're able to deliver clean heating and hot water and use clean electricity on the grid.
Yeah, I think that's a really important concept. It took me a while to really fully digest that, like, even if I'm using electricity in my home, that is only as clean as the electricity that's being supplied at that time. And what you're doing is enabling you to use it when it's cleanest.
Yeah, and I would say heat pump is pretty much always a good idea. They are 300, 400% efficient. That is going to be better than using a gas furnace or fuel oil in your home. It's just a question of, can we take it to the next step? Can we make it better? Not just from emissions perspective, but from allowing that grid to get increasingly cleaner. We want our electricity grid to be 80%, 90%, 100% renewable. That's really hard if we're all drawing electricity at night when there is no clean, cheap solar available. We're helping the grid get cleaner as well if we're able to maximize our use in the middle of the day. So it becomes an alliance between homeowners, what they're doing, and grid operators trying to reach those lofty goals of 100% renewable electricity.
Yeah, it's another example of where solving one problem for climate change has created another problem. If everybody were to switch to heat pumps today, to Gen 1 heat pumps, like you said, that don't have the load shifting ability, we would just create this massive problem on the grid because we'd have this huge electric spike in the mornings and evenings.
That transition is happening progressively. At the moment, we still have capacity on the grid for those who are adopting things today, but I think very quickly we need to transition to smarter systems. One approach that people ask about is, well, why not just get, lithium-ion batteries?
I was going to ask you.
That does do the trick. You can have a heat pump for space conditioning, a heat pump with a tank for your hot water, and a lithium-ion battery operating them. The challenge with that is, of course, fundamentally, you're adding more stuff, right? That lithium-ion battery is an additional cost to buy, to manufacture, to install. It's got a lot of minerals in there, which are also expensive and in short supply. But inherently, it is more equipment. And fundamentally, if you're able to take that tank, which you need anyway, and use it as a battery, then you're reducing that cost. It's also durable, it's safe, and it's basically just a storage tank, so it's cost effective. But yeah, I think one concept is lithium-ion batteries are absolutely fantastic for most electric loads. But when we think about a thermal load, such as heating and hot water, moving to a thermal battery is really the most cost-effective and durable way to go. So I think there's a place for both. But given that the heating and hot water represent 2/3 or more of the energy use of your home, if you already have, say, a Tesla Powerwall or another lithium-ion battery that's supplying some of your electricity to your home or providing some storage, that will not be enough. You would need another dedicated one for your heating and hot water, or maybe even more. So it's not a question of, oh, I've got one, I can use it for my heating and hot water. You can't. You would need another one. And in that case, given that you're going to have a tank, use that as your battery. It will save you money and it's going to work really well.
Yeah. So your solution, it sounds like, can be a retrofit or kind of if I have a home today with a traditional forced air system, gas furnace, and gas water heater, what does it look like to change all that out? Do I keep my existing hot water tank and some of my equipment, or how much of a retrofit are we talking about?
So essentially, most of our customers, what's happening is their gas furnace is getting old, time to replace it. They don't want to put another gas furnace in. And that's a time when they'll reach out to Harvest. We'll do some pre-qualification, put them in touch with a local contractor in their area that we've trained. And that contractor will go in and deploy the system. And it is essentially a full swap out. We're going to take out that furnace, replace it with an air handler at the same time, and a heat pump outdoors to deliver the heat to the hot water tank. And at the same time, we're going to replace the tank and put it in with a tank associated with the system. And so you're replacing essentially a prime driver is often, let's deal with the problem about heating. At the same time, you get the hot water and the load shifting for both of them. So it typically comes at the place of that retrofit. We have had a couple of customers who happen to have the heat pump that we work with for hot water already, and we're able then to leverage that and then just add on the heating part of it for their home. But for the most part, it is a full swap out of your heating system and your hot water system. That's why we go to market when people are that furnace is reaching towards the end of life. And those are the people we're targeting. Interesting enough, though, about close to 600,000 heating systems are installed just in the state of California every year. So just touching that would have a huge impact. And of course, beyond that, there are many, many millions more. But we're really targeting that replacement cycle.
When people are making the purchase decision, what do you see as being the main motivators? Do you help people just see the financial benefit? Is that enough to make the decision, or what does that look like?
Well, a lot of people now are really aware about the problems of climate change and also about, in a way, some of the challenges of burning gas in your home as well. And so there is a growing number of people who are saying, when my furnace comes up to replacement, I don't want to put another gas furnace in. I want a clean electric solution. So that's when people are coming to us. But what we're able to say is we can do this in a way that not just is going to save a lot of emissions and get gas out of your home, but it's also going to save you money, right? Month in, month out, you're going to be reducing your bills. That's really important because it means we have a positive payback compared to gas, which is challenging for many heat pump solutions. We're also able to capture a lot of incentives. The Inflation Reduction Act is one of them, but also there are a lot of local incentives coming for people in different zip codes, which is really helping with that upfront cost. But fundamentally, as we're reducing bills, that helps support financing, leasing, and really help drive those lifetime costs down for the homeowner.
And what about, I read something you wrote about the comfort upsides. Can you talk a little bit about that and why this actually, it's not, from a comfort standpoint, it's not even apples to apples. You're actually doing something different there too.
First of all, our customers are really, really happy with the experience, the comfort experience. The system is super quiet. The heat pump we're using has a peak a decibel of 37. 37 is really low. You can barely hear it. In fact, sometimes I have to put my hand on it to check if it's on. It's outside our daughter's bedroom, so it's super quiet. Very nice, stable heat. It's not drafty. You don't get the raw on, raw off that you do with a gas furnace. So this system is quiet. You don't know it's on. It's just delivering nice, stable heat and meeting all the hot water needs. We actually recently did a survey of our existing customers and asking that a lot of questions, including that Net Promoter Score question. Would you recommend this to your neighbors, to your friends, to your family? And we got a Net Promoter Score of 94%, which is really, really very high.
Yeah.
So the vast majority of our customers either strongly or just do recommend our system to their friends, their neighbors. We got nobody saying they did not recommend it at all. So that's really important, because at the end of the day, it is about homes and families and comfort. And you want to make sure that people are not just doing the right thing for the planet, it's saving them money, but also they're living a good, comfortable family life. And that matters a lot.
I think just to emphasize the sound thing with the heat pump, that relative to, so like I got a heat pump that's sized to heat my home directly, and it's pretty big and loud. I've got it outside our bedroom, and we hear that thing every time it comes on. And I guess what the advantage of your system is, you can be slowly storing up heat during the day when it's not needed, and then you're turning on the blower and your water circulation basically to heat the space as needed. So you don't need that huge heat pump to supply a bunch of thermal energy right on demand.
Do you know off the top of your head how many decibels your heat pump has?
I don't remember the decibels. I think it's a 4-ton heat pump. So it's pretty big. You're saying you don't even know if it's on. Like, I hear it through walls and it makes a big noise when it turns on and off. Like, yeah, I don't know the decibels, though. I'll look it up.
That was an important factor in us choosing this heat pump. And I think something to look out for when you're buying them. I think I've lived in a house where we had an external unit, and it was, if you were in the yard, it wasn't fun. You knew it was on.
Yeah, it's always on my mind. Like, oh, okay, there I go, using some peaker plant somewhere to heat my home.
You're using it efficiently. I mean, it is definitely, I'm never going to denigrate heat pumps. They are the path forward. They are the heroes of decarbonizing buildings. It's just, let's do it better. Let's do it smart.
There's these, like you've mentioned, incentives through the IRA, and I know there's been a bunch of progressive building codes starting to think about this stuff. Do you see those things starting to differentiate between Gen 1 heat pumps and load shifting solutions like yours?
Yes, there are various categories of incentives depending, say, on the efficiency of a system. But there's also things such as SGIP is going to be deployed, going to be rolled out, I think, later this summer in California. And that is self-generation incentive program, which is going to be hot water heat pumps are going to be eligible for that, typically to about $3,000, $3,100. Harvest thermal systems will get more. We'll get about $5,300 because we're able to store more, because we're able to load shift more. So we're seeing an advantage to our customers in getting differentiated incentives. Another one is Flex Market. Flex Market is an incentive in a number of locations in California, where SGIP is the whole state. SGIP Flex Market is in certain locations, such as the Central Coast and many counties in the Bay Area. And that is one where the aggregator is compensated for shaping the load to match the upside down duck that I was talking about before. And that's something that Harvest Thermal Systems do more than any other heat pump system there. And so our performance allows Harvest to get more incentives for that than any other system. And we pass these incentives on to our customers. So that's important. And then, of course, the Inflation Reduction Act has tax credits for the Section 48, which is for thermal energy storage. That's a 30% tax credit for systems with leases. And we're working towards how do we put in place lease models. And then there is a battery storage 25D as well, which is also significant. So there are, as the Inflation Reduction Act was helping drive towards cleaning up our economy and helping support renewables and building decarbonization as well, they've also been thoughtful about what's the impact on the grid. It is going to be hard for us to scale if we all electrify our homes at the same time and those heat pumps all run in the morning and at night. It is challenging for the grid to be able to meet that load. I saw a report on building electrification in the UK, but I've also heard people talk about it in California as well. I just haven't seen a report on that. And essentially, if all the homeowners in the UK transition from gas to electricity, which is what we want them to do, what we need them to do, it would require capacity upgrades of 42%. That's hard and that's expensive and that's time consuming. And so that's why when you see the Inflation Reduction Act or other incentives rolling out, people are being thoughtful about how do we also help people put in storage, do load shifting, because otherwise the cost to society of having to upgrade and transition our grid is going to be high.
One thing I was wondering about, as you scale, will you continue to have direct-to-consumer relationships?
Yeah.
Or is there some way to build that in a more scalable way?
Yeah, so there are multiple ways to go to market. And you're right. Right now, we've got good connections with the community. And a lot of people have reached out to us directly saying, I'm interested in your system. And on our website, we have a get quote process that will help you walk through, is the system available in my area? Is my home well suited to it? Are there trained contractors where I am? And walk through that process to get you started. And that's great. We've built a repeatable model in the Bay Area where we've now got over 30 trained contractors deploying systems. And on Earth Day in April, we just launched that in the Central Coast, so in San Luis Obispo, in Santa Barbara, and all the coastal communities there. And so that's rolling out. But really importantly, we want to scale. We want to help as many people as possible transition from gas in a way that's going to be cost effective and clean. And so we recently developed a partnership with Block Power, for example. Block Power is focused on how do we electrify homes in a way that's going to be cost effective, thinking of market rate, but also more disadvantaged and lower income communities as well. And the nice thing about that is that we're very complementary to each other, right? Block Power identifies homes and opportunities and communities that need to electrify. Harvest Thermal helps people electrify in a way that reduces bills. And so there's a natural affinity, and that's why we're partners together. So that's one way to scale. But we can also scale by working with, say, customers who have got renewable energy and solar. And we're talking about partnerships with solar companies in a way as well, because we help solar electricity become more valuable because you can self-consume it more. So that's really important. And of course, I want to work with new home builders and help. New home builders are on the front lines of regulations, right? They have to meet increasingly stringent building codes. And we are in discussion with a number of new home builders to help deploy pilots and bring that to scale. And I do want to say that we also want to offer services, in particular to grids, such as load shaping, such as demand response, to really help address the problems that the grid operators and utilities are grappling with every day. So multiple paths to market, and we are phasing through as we grow to increasingly augment our impact.
Services to grid. So that's like, as you scale and you have more and more people on the grid, is that because your system has the ability to change how and when it works to be more amenable to the needs of the grid?
Yeah, we were recently we're part of a project called CalFlex Hub. We're working with Lawrence Berkeley National Lab and the California Energy Commission, alongside a number of other manufacturing companies and product companies, to figure out how do we have a flexible grid in California. And just recently, we ran some demonstration of how can the Harvest Thermal technology respond to a grid signal. Let's imagine the utility is going to say, over the next 24 hours, this is when we want you to use electricity, and this is when we want you to avoid it. And the way they do that is by setting price signals. It might be a factor of 10 at 9 p.m. and then 2 p.m. and then 3 at another time of the day. What Harvest Thermal system does is, particularly when you've got that day ahead signal, we're able to plan. When are we going to run the heat pump? Are we going to make sure we have enough hot water to meet the needs of that household for the full day while meeting the needs of the grid? It becomes another signal for us, right? The Harvest algorithm takes into account what are the costs? What are the needs of the household over the next 24 hours? What are the emissions of the grid? But we can also take into account a price signal from the grid saying, please don't use electricity at this time. Please do use it at this time. What's really important is that we can do that, therefore be very responsive to what the grid needs and avoid brownouts and blackouts, but at the same time not impact the comfort of the homeowner because we've planned ahead, stored up enough hot water so they can still meet all their hot water and heating needs. That's really important because we can really shift that huge load to whenever makes the most sense for the grid.
Right. That makes a lot of sense. Yeah, we're signed up. We have a Nest thermostat and we're signed up for, I forget what they call it, but they're a similar idea where it says, we're at peak energy, lower your thermostat. But that just has a direct impact on our comfort. We have no ability to shift. So yeah, you can plan ahead essentially for that and store up the thermal energy.
Yeah, I mean, preheating, load shaving, that's really important, but there's a limit on what it can do before the impact on the comfort becomes unacceptable or not too much. If you can plan ahead and store up the hot water, which is what Harvest, the algorithm, is doing by looking at those price signals, then you can stay warm and still curtail your electricity use at the appropriate times.
Let's talk about the hardware. So I think do you call it the Harvest Pod? Is the custom piece of hardware. And is that right, that's the heat pump and the tank and the blower, the other aspects of the system are off-the-shelf?
That's right.
Pieces of technology?
Yeah. So we developed a control unit. It's called the Harvest Pod. It's about the size of a large shoebox. You can fit it next to your tank in the garage or tank closet or basement or wherever you keep your tank. That is what we build. That's what we manufacture here in San Jose. And that is really the brains of the system. It contains our electronics, as well as obviously the software embedded in that, as well as flow controls. It's got a couple of flow meters in it. It's got a number of temperature sensors in it. That allows it to monitor what's happening in the tank and what's happening, how much hot water is generated and delivered at various points of the system. It's also got a circulator pump for controlling the speed of the water. It's got a mixing valve to ensure that the water going to your hot water circuit is at the right temperature. And it's got a number of valves and controls inside it. So that is the harvest part. That's what we build. That's what we manufacture. And that really is the brains, because that is figuring out, when is this heat pump going to be most efficient? How do we make sure that heat pump, that we're managing managing the return temperature to that heat pump so it's going to operate optimally, and really figuring out when to run that heat pump. But then it's also looking at that tank and figuring out, well, what is the state of charge of that tank? And modeling it, using fluid mechanics modeling of what's happening inside the tank, but continuously calibrating it as well, so that we always know to within about 4 degrees Fahrenheit what the temperature is at any point of the tank. And I want to say it's a tank which is stratified, hot water at the top, a narrow thermocline, and cooler water in the bottom, which means, for example, in summer, Dylan, we might only be heating about 1/3 of the water in the tank. In the fall, about 2/3, and in winter, we'll be heating all the water in the tank. So we're modulating how much we're heating based on the needs of the household. Because we're calibrating, we're always planning ahead. How much is your household going to need? But reality is always different from expectations. So because we're calibrating, we're able to know, oh, you know what? They're using a bit more hot water than we'd expect. We'll make sure the heat pump comes on at an appropriate time to make sure they're never short. So we're always controlling, managing, and adjusting to make sure we meet the needs. And then, of course, delivery to the home. We're making sure that fan operates optimally. We're making sure we maximize delivery of heat to the home. And we're making sure that most of the heat is extracted out of that hot water, so that the water going back to the heat pump is nice and cool, which is a virtuous cycle of improving the efficiency of the overall system. So a lot's happening in that control system. But as you said, it's a third-party heat pump. I believe Rheem, Daikin, all the heat pump manufacturers, they're brilliant at doing heat pump R&D. And they continue to bring on board better and better heat pumps, and we're going to be able to leverage those. Using a third-party tank is just a storage device, have no value add there, and a third-party air handler, which is a commodity. But we bring them together and allow them to be smarter.
It sounds like there's actually quite a lot going on in your pod. Have you been using your PhD in fluid dynamics to design that?
Well, a lot of my time is taken up by managing the business and managing and driving things. I did contribute to all the some of the algorithms, but there are a lot of other really smart people in the company. Shout out to Pierre, shout out to Evan, shout out to Matthias and others, and who've really been putting it together. It really is that proverbial team effort.
What did it look like first? So you built a system in your home. How did it start, and how has it evolved since then?
Well, the first system, you know that I talked about all the things that are inside that pod. All those things inside that pod were all spread over a wall.
Yeah.
It looked messy. Lots of wires, lots of components attached to the wall in various places, and then working it through. The next thing then was to build our proprietary controller and have that in a separate box, which is making it a little bit smarter, being more predictive and so on. And then integrating it into a single unit, the pod. And that's really important because it allows us to factory assemble it, which means it's going to be more the higher levels of quality. It's going to be more reliable. It's also going to be more cost effective, right? It's easier to deploy that in a factory than it is in the field, where good conditions in the factory are not necessarily in good conditions in the field. It also looks better, right? People don't necessarily want to live through the type of mess I had on my wall in those early days. I'm really glad that we've now swapped it out. You know, I've had every version of the system. We've now swapped it out by a nice clean pod, which looks pretty nice and is clean and streamlined. Everything, all the mess is inside it.
I see. So another potential path would have been the installer comes and they've got a mixing unit here, they've got your control thing here, like all these different pieces, and it's a custom install or pieced together install for every home. But you've decided to integrate all of that into one cohesive unit.
Integrating it is better for cost, better for quality, best for customer acceptance, all those things. So we did it and started building those early last year and deploying them mid last year.
Does the system look and do the things you envisioned early on, or has it evolved based on feedback or learnings as you've rolled it out?
So we had this goal of making sure it was smart and could do predictive analytics and respond to, take into account efficiency and temperature. And we've been able to implement quite a lot of things that we planned. And then, of course, we're always figuring out new things to do. One thing that we haven't yet done, and we're really keen to do as quickly as possible, is that user interface, the app. Allow homeowners more control over what's happening. I mean, the system is automatic. It's set and forget. You don't have to worry about it. But people do like to know, well, how is it performing? How many emissions have I saved? Or I've got family coming for Thanksgiving. I want to be in boost mode, and so on and so forth. So giving homeowners that capability is actually now getting near to the top of our priority list as well. We're also looking at how do we expand it into colder climates. We are using a cold climate heat pump. The Senko 2 is a nice cold climate heat pump. But still, if you're starting to go to the East Coast where they have more extreme weathers, you need to figure out how do you integrate a backup into the system for when heat pumps struggle at minus 20 degrees. So how do we deal with that, and how do we optimize that? So for most of the year, it's going to be using the high performance heat pump and only using the booster for the minimal amount of time to really make sure that you deal with those colder temperatures. Because at the end of the day, we need to transition to heat pumps in all climates. And so you need to figure out how do you optimize that. So that's something we're actively working on with the goal of doing some pilots on the East Coast later this year.
Sorry, did you say it could work in minus 20 degrees?
No, what I'm saying is that if you're in a climate with minus 20 degrees, most heat pumps are going to struggle with that.
Right.
So there's going to be some kind of backup source.
Some other source of heat.
Other source of heat. So how do you integrate with that? How do we integrate so that we're always going to optimize harvest, but transition seamlessly to the backup whenever it's needed?
I'm still, even if minus 20 is too cold, I'm still shocked that heat pumps work in as cold a weather as they do. It's just mind-blowing to me.
And they're getting better and better. It is counterintuitive. When it's cold outside, a heat pump is extracting heat from that air and bringing it into the house. But when you touch your heat pump, as I'm sure you do on cold, you can feel cold air coming out of it. So it is extracting heat out of that air, releasing it even colder and bringing that warmth to your home. But it is amazing. I am always excited by it.
Can you tell me a little bit more about like the decision engine with this, or the analytics that are happening? Is there AI? What does that brains side of it look like? And is there any decision-making happening on the hardware itself, or is it connected to a cloud-based system?
So first of all, our system is designed to be autonomous. We have a cloud, but let's imagine you're no longer connected or you don't have a connection. The harvest pod will operate autonomously. The controls embedded on the system will allow it to operate. If you're cloud connected, it's even better. That allows us to take into account local weather conditions and update your rate schedule as the rates change and so on and so forth. But it is autonomous, because if you have a Wi-Fi outage, you still want to be able to deliver your heat and hot water whenever you need it. So controls, it's really about taking key parameters into account. So we've mentioned, what is your rate schedule? What is the characteristics of the heat pump? What are the emissions on the grid? And we will, and we don't today, but we will increasingly allow customers to choose what is their priority. Is it costs or emissions? The good thing is they overlap reasonably well, because in the middle of the day, we have time of use rates, so it's cheaper and cleaner. But there is some fine tuning that we're going to allow people to do. By default, we optimize on costs, but some people may prefer to optimize on emissions. So then it's emissions, it's costs, we're also looking into things like thermal load. So how long is this hot water going to have to be stored? And what is that trade-off between loading up, say, at noon for delivery at 5 a.m. and it's going to be stored all that time, or running that heat pump at 5 p.m. and having less thermal losses? So we're always taking thermal losses into account as well. And then it becomes that learning about, how does this household operate? We start up with a typical system, typical size of home, typical number of occupants. And then it's, well, you know what, this home doesn't seem to be losing heat very much in the evening. And therefore, I'm going to be able to learn from that and adapt to my forecast for the future days, knowing, for example, my house is west facing. We get a lot of solar gain in the evening. The previous house I had was not. And so the system's going to learn, well, they are typically using heat more or less in the evening or the morning. And we're going to be able to adapt, taking that into account, while continuously controlling and calibrating. So if something changes, we're able to catch up and make sure that you meet your needs. Homeowners just don't run out of water with our system. That is, I think, number one goal. Being the first user of the system, you don't run out of hot water. You make sure you're always monitoring. I'd say more so than a typical water heater system, because we're controlling that water tank more than most systems are. That allows us to rectify very quickly. Even if the electricity is dirty, we will make sure you don't run out of hot water.
Did you go through some times when your early prototypes weren't serving you as well as you wished? Did your family have to have some patience?
We had a lot of fun. It's also a question, we were learning, and our home was also the first laboratory. So we were doing things like, well, how do we calibrate a tank? What happens when a tank runs out? How big is a thermocline? So we're running experiments in my household at the beginning, right?
Yeah.
In the very early days. And so, yes, it was kind of fun and games, but those days are well behind.
Yeah. Thinking about the future, what do you want Harvest Thermal to look like in, I don't know what it is, 5 or 10 years? And yeah, how does that path look?
So I think there are a few things more broadly talking about how we think about heating hot water in our home. Today, if a gas furnace broke down, the contractor would turn up with another gas furnace on the back of the truck. I believe that in 5 years, that will be a heat pump. So that issue about emergency replacements will transition because heat pumps are becoming cheaper, they're becoming better known, they're better understood, and we're getting more market adoption and fantastic incentives and things to really spur that on. I really do believe, though, for those heat pump systems, thermal storage is the way to go to allow us to clean up our homes and have a renewable grid. So what I'd like to see is Harvest becoming the standard or Harvest-like technologies becoming the standard in new home construction. Thermal storage being understood and kind of a normal way to think about thermal energy and keeping the electrochemical batteries for the electric usage. I think there's a lot of growing awareness of the importance of this, and I think that will become much broader than it is today. I'd like us to have expanded, as I mentioned, up the West Coast, but also into the Northeast. And you can probably tell from my accent that I'd love to also expand into the UK and some of the European countries as well, where there's a huge need to transition from gas, not just for environmental reasons, but also geopolitical reasons as well. I want to be part of that.
That's awesome. It's exciting to think about not just all of the individual families that will benefit from this or homeowners that will benefit, but just as you scale, the bigger benefit it'll have at the grid scale.
Yeah, it becomes that virtuous cycle. More electricity at the right times allows us to put more renewables on the grid, which allows us to use more electricity at the right times cost effectively. It is a positive feedback loop.
Do you envision a world where we've solved the kind of renewable intermittency problem at the grid scale and we have enough, I don't know, load shifting batteries and things like that? Or is it?
There are multiple paths we can go down. We could imagine a world where we have millions and millions of batteries at the utility scale. That is a really difficult and expensive and challenging proposition on many fronts to do that. I think we will need to have some storage at that scale, but that shouldn't be the silver bullet. We don't need to have it for heating hot water, for example, right? We're just demonstrating that you don't need to have it for heating hot water. And the most cost-effective, practical way is to use thermal storage for heating hot water. So we may need batteries at the grid level for some resiliency, for some extreme circumstances, but we can use thermal storage. We can use behind-the-meter batteries for some usages. We can also use the complementarity of renewables in different parts of the grid. We're already electricity from California and it's going across state borders and it's coming back across state borders as well. So we can leverage what's available on other people's grids. So it doesn't have to be, battery storage at the utility scale is the solution. I don't think we can do that. And I think thermal storage is a really good solution to avoid a lot of costs and therefore accelerate our transition.
Makes sense. I'm convinced. Okay, I have 3 last questions. How optimistic or pessimistic are you about the future of the planet and why?
I'm an optimist because what's the alternative? I'm just focusing on what's possible and getting down to try and make it happen.
All right. Who is one other person or company doing something to impact climate change that's inspiring you?
There are so many. I've met so many great companies and great people on this journey. One example, though, that really caught my imagination is a company called EarthGrid, founded by CEO Troy Helming. I don't know if you're familiar with them.
No.
So they do plasma tunnel boring technology to make the installation of power lines exponentially faster and cheaper, scale up that delivery of clean, cheap electricity, because we're electrifying things. So we will need to expand the grid. Let's make that cheap and clean. And he's got a really exciting technology to do that.
Yes, I forgot about these. You mentioned this. I would love to talk to them. It sounds cool. What advice do you have for someone not working in climate today who wants to do something to help?
Well, it's the most exciting time to join the clean energy transition, right? There are so many things happening in the space, from a policy space, from a utility space, from a manufacturing space, from a software space. So I would say figure out what are your strengths. Make sure that you develop those strengths, right? These companies need all types of skills, from operations and marketing and so on. So really hone up your skills and then jump in and help out. Harvest Thermal, we're constantly looking for people with all different types of skills, marketing, sales, operations, software, and so on. So I'm sure there's a place for you. So just jump in.
Awesome. Well said. Well, Jane, that was really fun. I'm really inspired by what you're doing. I really appreciate your time today. Thank you.
Thank you. I love the opportunity and thanks for a great conversation.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.